So we're going to move on to applications of trigonometry, and the first one being the law of sines. So we're going to use the law of sines on non-right triangles. So that's a really important distinction. Those are non-right triangles that we're going to be using it on. So if we're applying the law of sines, we have to have some information that's very specific. So to have the law of sines, you need a pair that is an angle and the measure of a side across from the angle. That's required. So here, the 102.6 and the 25.3, that's a pair. So I have to know a pair. Then, in addition to that pair, I have to know either one other angle or one other side to be able to solve the triangle. So once you sketch all that out, I have a pair and I have an angle. I can actually find the measure of angle B by using the fact that there's 180 degrees in every triangle. So I can get that information directly from B. Now, if I want to start using the law of sines to find the missing leg lengths, I have two missing leg lengths here. What I can do is I can set up the proportion that uses the law of sines. Now, it's very important. A and capital A are pairs. C and capital C are pairs, meaning they're across from one another. So what I can do is I can take my pair of C that I know, and I can plug that into the problem. So for C, the length is 25.3, and then for the angle, I'm going to use the sine of the 102.6. Then I'm going to use my pair, so this would be 28.8, and the side across from it would be called little a. So that's my other pair. Then I'm going to cross multiply. So I'm going to do a times the sine of 102.6 equals 25.3 times the sine of 28.8. So that's a cross multiplication. And then I'm going to divide by both sides to solve for a. And we're going to round to the same place that's rounded in the triangle. So if the triangle rounded to 2 decimal places, you would round to 2. Then I can solve for the little b missing side. And I know it's little b because it's across from angle B. So I already found that angle B, according to the subtraction, was 48.6. So 180 minus angle A minus angle C. So if I'm looking, I'm going to cross multiply and then divide to get B as 19.4. So it's really important to look at when do you use these. I do have a triangle flowchart document that will help you know when to use the law of sines versus SOHCAHTOA or the law of cosines. Here's another application. Kurt would like to measure the distance across the river. So that's from B to C. He determines that angle C is 117.2, that the other angle A is 28.8, and then little b, which is across from my capital B, is 75.6. Now, at first glance, it looks like we don't have a pair here, which is required to do the law of sines. However, I can use the fact that there's 180 degrees in a triangle to solve for B. Now I have a pair. Once you have a pair, then you can apply the law of sines. So I'm going to use my little a being the length across the river because it's across from my capital, over the sine of 28.8 equals capital B divided by the the 34 degrees, 75.6 divided by sine of 34. I'm going to cross multiply and get 65.1. Now, this is another application problem where the bearing of a lighthouse from a ship is found to be north 52 degrees west. After the ship sailed 5.8 kilometers due south, the new bearing is north at 23 degrees. These are the problems where we can get lost in the words. So what you're wanting to do is to start drawing. And what's important when you start drawing is you want to start from the origin or this vertical line of north. That's where everything is oriented to. So when I'm going north and I go 52 degrees west, I go towards the westward direction, 52 degrees from here. Not from here, from here. Then after 5.8 kilometers, its new bearing is going to be north at 23. Here's my new bearing, at 23 from the vertical. Then I'm just going to solve my triangle utilizing the same methods and the law of sine process. But the sketching of this is where it can get a little bit tricky. And I'm just going to go through the calculations. Again, it's pairs of sides and angles. So this one, I have no sketch. I have no word problem. I have no information, and they have my angle in minutes and degrees. So what am I going to do here? I'm going to use the law of sines to find capital A. So if I do that, then I have a pair, C and little c. That's a pair. And I have little a. So I don't actually have to sketch the triangle here. But it's very important to use your calculator to either enter the angle as 75 degrees 30 minutes or to convert 30 minutes to degrees by doing 30 over 60. So you would do 75 plus 30 over 60 to get that. And we would round to the second decimal place because the minutes has 2 decimal places. The lab in general, if you just click show me how to solve this or help me solve this, it'll help give you an indication of how far out you need to round, or it typically does tell you that information. Now, since the sine of A has to be larger than 1.31, because to find the actual A, I'd have to take the inverse of both sides, then no such triangle will exist in this case. So it is possible if you get a value larger than 1 or smaller than -1, that it's not possible to make a triangle. And you've got to recognize that because from here, you would probably just take the inverse sine of both sides, and then your calculator would just keep saying error, error, error. Or domain error. So we have to recognize when we don't have an actual triangle that's going to be there. Now, here's another example. If I attempt to sketch a triangle and it leads me to this odd figure here, what does this tell me? Well, I have this small triangle right here, and then I have this 75 degrees and 30 minutes. So this is what's happening here. This is why I can't complete my triangle. Because if I actually measured out this answer, oops, that answer, I wouldn't be able to complete the triangle. You see how there's a gap right there? So that's what that answer is actually telling us. Now here, again, I don't have to draw the triangle because of the naming convention. So I have angle A, I have side A, I have side B, I don't have angle B. So to find angle B, I'm going to use the law of sines. I'm going to fill in my information. I'm going to cross multiply and then divide both sides by 35.5. Now, I need to solve for b, not sine b. So I'm going to take the inverse of both sides, and I get 0.9695. That's perfectly okay. It's between -1 and 1. And when I do that, I'm going to get 75.8. So now, if I want to find the second possible angle, it would have to be smaller than 180 and be located in quadrant 2. So I would take 180 minus that, and that gives me a second option for that angle because it says there are 2 angles between 0 and 180 because sine is related to the y-axis, which is positive in both quadrants. When this happens, we're going to solve these independently. If angle B is a 75.8 degree angle, I'm going to get 42.8 here. Then I'm going to solve for my C, and in that case, I get 42.8 for my side. If I solve it for the 104.2, I'm going to use that 180 minus. I'm going to apply the law of sines, and in this case, I'll get 14.4 for the C and 10.1. Here again, I don't need to solve this by sketching because I know my pair is B and little b. So I'm going to fill in my proportion, cross multiply, divide both sides by 25.4. I get something between 1 and -1, so that's okay. But I have 2 angles for which the sine is going to be positive, a quadrant 1 angle and a quadrant 2 angle. So I have to, again, split this off into 2 possible triangles. So once I do that, I'm going to split it off and I start looking at, well, with what I'm given, let's go back to the other side, 68.7, can I have 68.7 and 134 in a triangle? So even though it's positive in both quadrants, That can't happen because if I add 134 and 68.7, that's greater than 180. So there's only one possible triangle, and we're going to use the 46 degrees to figure that out. So I'm going to use the 46, subtract from 180, get my angle C. Then I'm going to plug in my proportion to get my value for the C and the little c. So without using the law of sines, explain why no triangle exists that satisfies B is 93 degrees, B is 42, and C is 48 centimeters. Because this makes it an obtuse angle, that must be the largest angle of the triangle. And what our rules with angles and lengths of sides says is that the longest side is opposite the largest angle. Well, I can't have two obtuse angles within a triangle. That's a problem. So there's not a possibility of making a triangle here because little c is 48 centimeters, which means that that angle, capital C, would have to also be obtuse and larger than 93 degrees, which is not possible. Then I'm going to exceed the 180 degrees. So there's no such triangle that would exist here. Even without launching into the law of sines, I can just look at it and know that. Now here's the other one. If I want to find the area, this is an adaptation of the law of sines. I can do 1/2 the included angle times the length of the sides that are included in the angle. So I need an angle between two known sides. I need a known angle side here. I'm going to plug in, and there's my area. So the area of the triangle is not a bad calculation. You just have to have an included angle, which means an angle that you know, between two side lengths that you also know. Here's another example. In this example, I can't find the area because I don't have two side lengths. But I can use the law of sines so that I can find those missing side lengths, and then I can find the area. So once I apply the law of sines, I get that this side is 37. Now I have two sides and the angle between, and now I can actually launch into that calculation. Again, if your calculator is not equipped to do degrees and minutes, you want to use 73 plus 30 over 60, which is 73.5.